You're listening to Materials Business, the podcast where engineering, leadership, and innovation meet diversity and inclusion. Hosted by Monica Hernandez, engineer, entrepreneur, and industry advocate. When we embrace different perspectives, we create stronger industries, smarter solutions, and lasting impact. Now, let's dive in.
Good morning, good afternoon, or good evening, depending on when are you watching us or listening to us. And thank you for being part of the material business community. I'm very excited for this first episode of 2026, and we have Josh Harrison with us. We're going to speak about, we have a forest problem, and then that ties into what is that we do at material business. We talk about materials, we talk about sustainability, and the interconnection and all that. And I'm very happy because we have never had someone that has worked in that area before, in the wood area. So it's a really good episode to kick the new year. Josh, thank you for being with us today.
Monica, thank you for inviting me. I'm very excited to share some of the really transformational things that are going on in this world, and how we deal with wood materials is one of those areas that's just expanding and growing, by the day.
It's very interesting that you say that, because one will think that the industry is not going up or progressing as other industries are going. And then when we were having chats offline, you mentioned something to me about there is a problem on the way we use our resources from the forest. So I'm very intrigued about that. Can you tell us a little bit more about that?
Sure. We have a huge problem that we're all aware of with fires and with the impact of too much carbon loading in the environment and many, many other things. And some significant portion of that is involved with how we have managed the forests in the United States and Canada for the last 250, 300 years. And primarily what we've done is we've done two things that have come back to bite us pretty severely. We've ignored the traditional native understandings that fires were a part of a regular occurrence in the landscape, not to be feared, not to be suppressed, but to be controlled, managed, and directed towards socially, ecologically, and medicinally beneficial uses. And that's particularly evident in the Western states, which have a Mediterranean climate. I'm in California, which is probably the poster child for poor forest management. That's one. And the second one is we've treated forests as a resource that's a one-way resource, where we've extracted the wood from it without thinking about how we repair, replace, and regenerate the soils, the forests. And in doing so, we've ignored the tremendous value that a functioning living ecosystem provides to all of us in all kinds of ways that are not necessarily obvious when you don't think about it, but once you understand it, they're implicitly obvious. Forests are a big reason we have rain. Forests are a big reason we can breathe. Forests are a big reason that flooding doesn't happen as badly as it can right now. There's a terrible flooding problem in the Pacific. Part of that, not all of it, is due to the larger climate and weather cycles, and part of it, not all of it, is due to poor forest management that has made the soils less able to hold water, that has made the erosion problems more difficult, and we've done many, many different things. In a certain sense, we've neglected to be beavers by eliminating the beavers. So by doing that, we've ended up with a lot of, other ancillary problems. That said, we are in a really powerful turning point, where this very capsule summary of 250 years of poor land management and poor understanding of fire and fear of fire that came with the Western colonists to North America and South America as well, where fire was a really scary thing in Europe. You had old wooden houses. They used fire for heating. They used fire for light. That meant lots of things, lots of bad things could happen with that. So obviously the idea that they came across native people who intentionally set fires was a really scary thing. And they behaved as the colonists always do. They suppressed it. They actually killed people for setting fires. It was penalty of death at some point in the early missionary settlements in California. So it was a very seriously suppressed, to the point that a lot of local knowledge just was suppressed as well. And that's been a recovery process that's going on. That said, without getting we can spend a lot of time on the details of that, but I think let's talk about how we respond to that. The biggest point of understanding and intuition that's been difficult for many of us to realize is that what that suppression of forests have meant is that the forests have overgrown, just like a garden that you ignore gets overgrown. And just like in a garden, if you have too many plants, they don't get in. They compete for light, they compete for water, they compete for nutrients. And instead of being stronger, they often get weaker. So we have that first manifested itself in California with massive disease die-offs from infestations of beetles and other predator invasive species, which the trees were prior to that had been able to be resistant. But as they get weaker cumulatively, they started to become more susceptible to disease. There was great die-off. That also spurred the lightning fires and strikes, and also the utility grids, which have overhead high-tension wires that throw off sparks on a regular basis, turn out to be a major contributor to setting off fires. One climate just point of all of this is in a Mediterranean climate, this is exacerbated because you have a wet wintertime, which inspires a lot of growth, and then you have 6, 7, 8, 9 months of hot sun with very little rain. That means all that stuff that grew brilliantly in February, March, April starts drying out and, of course, becomes tinder by August, September, October, which is historically peak fire season. So it's all of these things build on each other. You have too many trees, and just one modest example, if you look at a mountain landscape from afar and it's all covered in green, except maybe in the west there's some granite here and there, but that stuff that isn't granite is split in green. Most of us have the instinctive sense that looks healthy. That's great. But what historical research has shown and what current science understands and what the people who lived here for millennia already knew and just were being ignored about is that a healthy Western forest isn't overcrowded. So that number of trees, to get a full canopy cover, it's 350 to 400 what they call stems, individual trees. But a healthy forest, we can go into the research later if you're interested, but only has 35 to 40 stems in California. That's before climate. So we're talking about an order of magnitude for wood and woody products and shrubbery and all kinds of things than historically was there. Just as a point of reference, John Muir talks about in his diaries riding 3 horses abreast in the forest. Okay, the early settler diaries record people in Conestoga wagons riding without need of roads because the trees were so far apart, except obviously where the land didn't permit it. So that's the level of overgrowth that we're fighting. And that's what's burning. And that's what's eventually getting back into balance. Now, when you're taking all that wood and it's burning in a fire, all of the good carbon benefits that 250 to 400 million years of evolution have trained photosynthesis to do, to suck carbon dioxide in and turn oxygen out, all that gets reversed. So instead of being carbon absorbers, many, many parts of the United States and Canada now are net carbon emitters because of the fire.
Of course.
Okay, so it's not intentional, but that's one of the matter. You burn stuff, goes up in the air, and carbon dioxide. You also emit a lot of even more toxic things than carbon dioxide, but carbon dioxide is a particular problem because it has a great deal of durability in the atmosphere. Many of the other black carbon, which is much more toxic, methane, which is also more toxic and much more of a carbon problem, have much shorter half-lives in the atmosphere. So we want to reduce the amount of carbon for all kinds of reasons, and we want to reduce the amount of introduced carbon. There is a carbon cycle, there is a natural balance. We pushed that natural balance beyond measurable convenience. Okay, so now what do we do with all that extra wood?
That would be my next question.
Exactly. That's exactly the problem. That's the problem. Okay, so once that was sort of understood in the mid-2000s, then the question is, it costs a lot of money to do that, although just as a point of relative balance, it costs about anywhere from $1,000 to $2,500 an acre to selectively, intelligently, ecologically identify what needs to stay and go on a particular forested landscape. That of the 32 million acres in California times that's a lot of billions of dollars. If we do roughly 1,000,000 acres a year, 500,000 in the private and state sector, and 500,000 because so much of California is run by owned by the federal government. We're not going to talk about the current policies of the federal government at the moment, because but when we had a federal government that was actually interested. If you go 1 million acres a year, that's okay, call it roughly $3 billion a year by the time you're done. Now, just as a point of reference, the fires last year in Santa Monica, in July, the first estimates were $164 billion of damage. One set of fires in a 6-week period. That number has undoubtedly probably doubled by the time the final costs are in. They had a $1 billion with a B dollar master plan in 2018 to deal with the most serious and significant areas that were exposed to fire in the urban area in the Santa Monica Mountains. They spent about half of it and decided it was too expensive. So let's just think about that for a second. So yes, it's expensive, but it's nowhere near as expensive as not doing anything. It's what I call the high cost of doing nothing. So next step, once you clear it, so fortunately, Washington, Oregon, again, I can't speak as well to British Columbia as well, but they're all understanding this. This is no longer strange and new information for people who are connected to the forest. What implementing is another story, but let's go. We have, just to stay in California, because I think it's a useful connection. Of these millions of acres a year, most of that is smaller diameter timber, smaller trees, woody, what they call biomass, shrubs, mid-growth, undergrowth. Some of it are larger traditional lumbering trees. So problem one, most mills, most people who handle wood don't really like to deal with the less valuable aspects of the timber harvest. In an ideal world for them, they would just leave them on the ground and walk away. Typically, a timber contract in California doesn't let you do that anymore. It doesn't mean that it's obeyed. But nonetheless, you end up with a lot of things that don't have an immediate. But that's problem one. Problem two is wood is really heavy. The good news about wood is that about a cubic meter of wood of a trunk, it weighs about a ton, and it's roughly, depending on whether it's hard or soft wood, about a ton of carbon. So a 30-foot tree is roughly 30 tons. A 30-foot tree is roughly, so there's significant amount of carbon stored in that tree. At the same time, wood is really heavy. A 30-foot tree weighs 30 tons. You can't take 30 tons up and stick it on your shoulder and hike it out into somewhere else. And it requires a certain kind of infrastructure. It requires roads, not just roads that are simple paths. It requires roads that are well enough designed that a logging truck, which is roughly a certain dimension and needs to be able to make certain kinds of curves and turns, can actually negotiate that road. And then the wood has to be within a certain distance. So there's technical issues of that. And then the third one in California adds to California is both the worst offender because we've suppressed fire in California longer than anyone else, because Spanish missionaries came to San Diego in 1707, and most of the West was lumbered in the 1850s. So California had a head start, on mismanaging the landscape. The climax species of trees in the central Sierra Nevada and much of California are Jeffrey pine, ponderosa pine. They're softer woods than the Douglas firs and spruce that grow further north because it's cold. Okay, they're not a lot softer, but that softer wood means they have less prehensile strength. They're slightly less structurally reliable. Therefore, in the building industry, over the last 40 or 50 years, because 50 years ago, when people didn't import wood from far away, it didn't matter. And so if you're looking at any house in California that's made out of wood and it's not redwood, it's likely ponderosa pine, Jeffrey pine, or one of the other softer pines. And somehow they manage to survive. So it's like, but being that the building trades are relatively conservative and nobody wants to be the guinea pig to try something new, these woods don't really have anywhere near the commercial interest. So now it's heavy. There's a lot of it. It's not in the right form. A big chunk of it is not in the right form factor for traditional logging operations. It's heavy to move. And, the industry itself has collapsed in a state like California, where there's roughly 30% of the wood infrastructure that there was in 1990. So that's a 70% drop. So that's a way to handle it. And then finally, what do you do with it? So that's the big hairy problem that people have been struggling with in different ways. There's lots and lots of conceptual answers, but the basic thing you want to do with would like, I mean, it's again, okay, we set up a little algorithm. You can burn it, you can bury it, or you can build it. Burning all that extra thing, which is what the state wants to do, is basically a carbon transfer. Okay, it's naturally produced carbon. It saves us for if we burn it instead of something we've dug up, instead of a fossil carbon, somehow we're making the world safer for everything. No, it's a pretty mediocre. It's like many quick fixes. It sounds good right now.
A little plaster.
Oh yes, yes, but there's a lot of interest in pelletizing wood, and shipping it to Japan as a coal substitution. Um, and burying it is useful in limited ways. We aren't doing anywhere near enough compost. There's lots of local solutions. If you live in an area of a lot of wood, there's no reason you can't use wood as a local fuel. That's very different. There's no reason, there's lots of anaerobic conversion processes, generally under the word of pyrolysis, that incompletely burn wood, giving you access to lots of potentially valuable chemicals, as well as some of the energy that's in that wood, as well as leaving you with really useful kinds of output products that are good for soil additives and substitutes. They're economically not scaling at a large level. That doesn't mean they won't at some point. That's, I think, from your audience in particular, there's a lot of rich interest in basically anaerobic conversion, because you have multiple outputs. You can use those materials in multiple ways, and you end up with a biochar, which is a really potent form of carbon that's both a powerful soil additive, and again, it's lots of industrial uses as well. So that's another one. And then the most important one from the perspective of what we're talking about is, how do you park that wood fiber in buildings over time that can last and endure? So the goal for any kind of carbon removal from the atmosphere is to get it out of the way for a minimum of 80 or 100 years longer if possible.
Wow.
Otherwise, you're not doing. So buildings that people aren't designing to tear down are pretty good tool for that. At the same time as all this has been happening in the United States, people back in the old country of Europe haven't been sitting on their toes. They've had forests for a long time, and as a part of a series of engineering decisions, they started to think about how we can turn wood material into really stronger concrete. And it's really designed as, can we make wood a replacement for concrete? They came up with a category of timber products, which generally are called mass timber. And mass timber is a variety of different ways. You can think of it as basically the same principle behind plywood. You cross-match fibers in different ways, and you multiply your strength. Now, the first large use of that was in something called glue-lam, or glue-laminated beams, which are, I imagine most of you and your audience have come across them in different ways. They're very common ways to create really powerful structural supports that can be manufactured to order. They're not and they're basically done in the same way. They're just layered wood, cross-laminated, and put. The larger conversation, though, sort of looks at plywood, particularly either in sheets, something that's now called mass plywood, or in mass timber. And mass timber is actually traditional wood, 2x4s cross-hatched and glued together in different ways. And when you look at mass timber products, which then range measured by the depth, how many inches deep it is actually structurally stronger than concrete or steel. When you look at it, because the 2x4s, as they were, are laid together, there's very little air movement. So it's actually not only strong material, it's actually more fire resistant. And burn tests have shown this. Why? Because it chars, it doesn't burn. So it maintains its integrity, maintains its structural integrity longer than comparable steel and concrete. Again, it's a really good material. It was not designed as an ecological material per se, but in Europe, they were already thinking, if we're going to be efficient with our materials and we don't have large natural supplies, and concrete is after water is the single most used material on the planet. Number 2 is concrete. So also concrete is about because of the heat it requires, because of the rebar and structural reinforcement to go into it, between steel and the concrete manufacturing process itself. Somewhere between 5 and 7% of global emissions are there. So it's a significant contributor. So anything that we can do to pull it out. Now, as we're talking, we have an all of the above strategy. People are working their damnedest to figure out how to make concrete less energy intensive. They're figuring out how to make concrete that can self-repair. They're figuring out how to add moss and other bioreactive products into concrete. All great. This is an all of the above strategy. Nothing, when you're thinking environmentally, everything, not everything, but there are many answers. There's not one answer, and there are many places, and you have to think bioregional. What are the right materials for your area? What are the right materials for your region? What are the right solutions? And there's never, we're not a magic bullet. One of the big mistakes we've made over time, and it comes out of, this techno-optimism, is that there's a big fix. We just do a big fix. We check it off. We don't have to worry about it anymore. No. We're all going to have to be involved. We're all committed. And there's lots and lots of good fixes, very few perfect fixes. And we have to live with the fact that the perfect is the enemy of the good. And we are going to have to we're going to have to settle for good enough in all kinds of ways. And good enough is more than good enough, because that's the way we all adapt.
Yeah, you've touched on very, very, very important topics that we've discussed. I think in all of the episodes that we've released so far. I'm sure we'll keep talking about it. And one of that is collaboration. The other one is making sure that we don't, like you said, the solutions, there is no one solution. There is a multitude of solutions that together will work to get us where we want to be. And that there is no sustainable, and I've said this a lot, we cannot guarantee a transition in energy if we don't create sustainable solutions. And we have a lot of knowledge that, like you said, we are trying to relearn because somehow we've lost it, because someone thought this, my big idea is the best idea, let's go with my idea, and then forget all about it.
Right.
And then somehow, if we think about what you were saying, 80 to 100 years, like we won't be here. So we need to take in consideration that fact that the decisions that we are taking today, we are inheriting it to the next generations.
Absolutely.
And
And
that
the
is
generation beyond that.
after that. So it's like, I said this all the time, like, what are we leaving to your kids and my kids and your grandkids and my grandkids? It's like, what is it? So it's a huge responsibility. As you were speaking about this new era of using the wood material, I couldn't stop my mind but imagining we have something like that in materials, like conventional materials, and it's the composites, right? Where we put like a fiberglass, or so it's a fiber that goes in different directions with an agglomerate that sticks it together. So for those of you that are listening to this, that's a mental idea that you can have on how this compares to some of the materials that we're normally using, carbon fiber or Kevlar or some of those other materials that are structurally similar to what Josh is describing. Another point that you made that it's incredible is this has, normally when we think about the wood, we see all those beautiful trees in the forests. Like I go to the walks in the Rockies and in these beautiful big trees. And we of course think they are strong because they are alive, they're connected to the earth and all that. But then when you think about construction, you kind of remove that strength out of the equation. And it's like, oh, it's just wood. And it's not, based on all the knowledge that you have given us in these 27 minutes of discussion. So it's a lot of really good pieces that come into place. Can you remind any any project, or can you give us an example of when you have worked with materials that were built in these with these structures, maybe that was successful, maybe that will
Sure.
give the audience a good.
Okay. So the really good news, and it's kind of another of these same stories, is that mass timber buildings started being built in Europe in the 1970s. So there's a long history and tradition. Over the last 10 years, mass timber has started first in Canada, and then it migrated down to the western states. Portland and Oregon in particular has been a leader in mass timber production. Washington not far behind, and California is now the single largest market for mass timber buildings in the United States. Not surprisingly, it's a ginormous estate, right? Um, so there are many buildings, and there are many good examples. And I think that there's the tall wood structure. The Portland airport is now recently opened entirely out of wood. There are, just to give some basic examples, there's probably 25 or 30 signature buildings in San Francisco now under construction. With about 5 or 6 years ago, the ISO finally approved some international voluntary standards that regulated mass timber construction up to about 21 stories. Those are generally the taller built. Up to 11 stories, it can be entirely wood. Between 11 and 21 additional amounts of concrete around a central core and construction are required. They're moving closer towards removing the concrete, or minimizing and reducing the amount of concrete required. And they're also increasing the number of floors and carrying capacity as they get better at it. So, but right now there are quite a few buildings made. And again, a friend of mine 2 years ago was invited to Michigan State University to open up the mass timber studies work there. And now the upper Midwest has its own forest basket. It has its own set of trees, and they're starting to make mass timber out of that. The southeast of the United States is actually exploding in mass timber. I'm not entirely happy with that, because they're also exploding in a much more industrial development way. And a tree farm is not a forest, as we say. And a tree farm, if you're going to farm fiber, farm bamboo, farm hemp, much lower cost, much lower intensity, big bang for your buck.
And quicker
returns, better carbon, better short-term carbon. Your maximum carbon in a tree is 80 years out. No farm wants to wait 80 years for their trees to harvest, so they're going to harvest them sooner. They're not going to get the benefits that they would get if the trees were fully matured. And if the trees were fully matured, they couldn't plant them 2.5 feet apart. So again, so there are better and worse ways to do things, and anything that doesn't think in cycles, as you were talking about with your kids, that doesn't think about the reciprocity of the process, that doesn't think about leaving the soil healthier, leaving the water retention power healthier, leaving the carbon capacity stronger. As we say in my center, we look for projects where the harvest preserves the system, where the act of what you're doing maintains or improves the integrity of the landscape from where you're doing it. And in a certain sense. So again, we can do things well and we can do things poorly, just like, there's a use for, there are plenty of uses for industrial chemicals. We use them too often, too frequently, and too widely. That doesn't mean there are no uses for them. Doesn't mean the same thing for plastic. A plastic-like product is incredibly valuable, but we can't have plastic uber alles everywhere, without. And we understood that when we pretended we could recycle plastic. The plastic industry basically created this fantasy that we could recycle plastic instead of making plastics that could be recycled.
Yeah.
Instead
it's used to, it's like, I remember when I was a child, my mom will send me to get tomatoes or potatoes. And then I'll use the same plastic bag for like 3 years until the plastic bag was already so worn out that I couldn't use it anymore. It's the same plastic bag that carried potatoes, tomatoes, pineapple, whatever so
or 20 years before that, it would have been a woven bag out of a natural fiber.
Yeah.
Or a straw bag, or a twig basket,
Exactly. Yeah. So
all of those are equally. You know what they're doing in Singapore now? They're now wrapping food in the supermarket in banana leaves instead of plastic containers.
We used to do that as well in Colombia. The cheese that comes out like fresh out of the farmer will come in banana leaves.
So why not return to that?
Exactly.
Why not return to that? What is keeping us from doing where you have a lot of banana leaves? No, of course, you're not going to import banana leaves to Vancouver for that kind of industrial process. But in Colombia, in places where where it's
It's just
common.
part of that circular economy that we keep
That's right,
talking about.
exactly.
Is like, how can we use everything that we have right here?
Mhm.
Not elsewhere, but right here.
Right. And that's, again, tied into keeping your dollars, your money local.
Absolutely.
And that
Absolutely.
way the people who live there get the benefit of it. It's not being exported somewhere else by somebody far away who really doesn't care whether you have a good life or a bad life. They just,
Absolutely.
so keep
Josh, I am enjoying so much this conversation. The time is almost up.
okay,
Before we go, I want to ask one question. I want to ask two questions because
sure.
we didn't did that at the beginning. The first question I want to ask, and maybe this is sort of just picking up your brain. There is a lot of companies out there, like even like I don't know, maybe I get one message a week over LinkedIn, like we can help your company offset the CO2 emissions by planting trees. And then there is all these companies that kind of sell that dream that it will help you. But then listening to what you're saying is like, yeah, this is probably not a really good idea because who knows what is it, the studies that they have done. So we are not
Well,
reforesting something that is already overpopulated.
well, I think again there are every ecosystem grows differently. And
Mm-hmm.
what's true in the Mediterranean climates, although there are a lot of Mediterranean climates around, is not true in a rainforest or even in the Pacific Northwest rainforest. Fire comes there differently, but so that's one thing. But I would say your instinct that offsetting your carbon, buying carbon offsets is not necessarily fully realized its potential and what they call there's more greenwashing, that is to say, it makes you feel good than it actually succeeds, is very real. First off, we definitely do need to plant more trees. That's not a problem. There are many ways to do that, but you can't just plant a tree. You have to nurture that tree. So anything that is just planting trees that doesn't include how those trees are going to be supported to their own maturity where they can self-sustain is, again, that's a perfect example of greenwashing. Somebody is going up in a plane and they're throwing hundreds of thousands of seeds out in the air, and then they're saying, okay, this, or even if they have a nice little planting brigade and they go in and they plant individual trees and then they give you the count. If they're not going back there on a monthly basis to make sure it's going on or whatever on some kind of a regular care regime, then it's the same thing. So that's just 1 point. Two, most of the carbon offsets don't require the person buying the carbon offset to change their behavior.
Yeah.
So it's actually not a solution. It's
Yeah.
even in a more broad, carbon offsets only work in tandem with ratcheting down on the behavior you're trying to offset and with visible, meaningful teeth that allow that ratchet to happen. Now, if that is in those cases where that is the case, then it's a win-win situation. You're getting more trees that are being planted in a way. I tend to shy away from the word sustainable because we're in a bad state. Sustainable implies maintaining the status quo. And actually, we can't really maintain the status quo. Right now, the term of art is regenerative, but that's probably going to wear out its welcome pretty soon. And we'll move on to some other term that gets, overused and its meaning gets diluted. But as long as you do that, as long as these are tied to meaningful ways that address what your problem you're trying to cover up is, then sure, absolutely, we need more trees. But it's telling to note that the chief scientist of the Trillion Tree Project, Thomas Crowther, and his wonderful lab out in Geneva, left the UN Trillion Tree Project because he didn't think it was actually working the way it was.
It should be.
Stopped working regeneratively to help forests grow in different ways and being in it, getting involved in some really amazing work. But he's no longer the public and scientific mouthpiece for that particular project because he felt in the end it wasn't delivering. It was more, I just what all hat and no cattle, as some people say.
Yeah. It's just, I normally say that when I am in the keynotes that I deliver, and I'm like, this is just a check mark. So that's very insightful. Josh, thank you very much. If there is someone in the audience that want to get to find you or talk to you about this or any of the other things, maybe in a little short description, can you tell us about you and then how can they find you?
All right. You can find me. I direct an art science environmental collaborative called the Center for the Study of the Force Majeure. We're based at UC Santa Cruz. I myself live between New York and Santa Cruz because we have projects in forests. We also work in the ocean. We work with both low tech and high tech functions. The website's a mouthpiece, but I'm sure you'll put it in the speaker notes. I also advise two companies, one a forest products company called Fabric Mass Timber that basically is walking the walk, in my opinion, that I've been talking about. They have found ways to take the specific wood from California that we discussed and are starting to put it into building materials. So most of that mass timber that's in California now is imported from somewhere else. So it's helpful somewhere else for the environmental benefits, but California isn't. And also California has at least a 2 million housing shortage. So they have a desperate need for the kind of housing that actually supports living communities. So that's one. And the other is called Leaf Island. And Leaf Island is a green roofing company that we basically upcycle styrofoam, which is 30% of landfills by volume in much of the world. It's a terrible problem. We don't know what to do with it. But the things that make styrofoam a waste product that's not helpful turn out to be very helpful in manufacturing an artificial soil that's extremely lightweight, so light that you can actually put it in building morphologies that would not otherwise support. Again, what else is heavy? Wood is heavy. Water's heavy. What else is heavy? Dirt's heavy. Water and dirt together plus plants are very heavy. Being able to create a bioproductive, bioreactive, artificial soil that weighs less than the standard carrying capacity of coated roofs all over the country is a really important way into the thing that's really important for any kind of green infrastructure: affordability, access, universality.
I feel like we need to have another episode. You're so interesting, Josh, and then everything that you've shared with our audience today has been magnificent. I've learned so much. You were right. We'll put all the comments below and then in the author connections and all that. So maybe just bring up this episode.
Thank you so much. Go ahead.
Why do you think people should listen to the Material Business Podcast?
I think that we don't pay anywhere near enough attention to the actual physicality of our lives. Goethe has a wonderful statement, "Man ist, was ist. You are what you eat." And he meant it literally. And we are what we live in. We are what we consume. We are how we deal with the world. And the smarter we are, the more intuitive we are, better we understand that, I think the better positioned we are to say, wait a second, I don't need all that plastic. I can live differently. Wait a second, why don't I have clothes that last decades? Why do clothes disappear? Why are the fabrics so overtreated? And so, because again, fabric, clothing, and fashion is another giant contributor to the issue. It doesn't have to be, sustainably, or again, I don't like that word, but well harvested fibers in the right place. We don't need to grow cotton in a desert, but we can grow cotton where there's water. We have all kinds of animal furs and hair that we can reuse. We have all kinds of proteins that we can make out of algae. Seaweed algae is now an amazing source for all kinds of materials, including really, really comfortable, durable fiber. Why aren't we building clothes that last for decades? Again, why is that? It's the materiality of the things. Why do things look like they're shabbily made these days? Why don't we have a right to repair? Why don't we have an understanding of how durable goods are truly durable? Why do we have so few durable goods? Well, all of that's part of the material understanding, the material science, and the material process. So, the material business, and people who study that and who learn that and get into that are really, they're part of the really internal gears that we don't think about and we take for granted, but we should be thinking about and we shouldn't be taking.
Absolutely. Josh, thank you. It's been a pleasure having you. I'm for sure going to look into having you for a next episode and talk about all the other amazing stuff that you're involved in.
Happy to come back. Bye-bye. Very pleasure.
Bye-bye. Thank you.
Thanks for listening to the Materials Business Podcast. Feel free to visit infinitygrowth.ca to see show notes and explore other episodes. If there's someone you think should hear this episode, please share with them. Take care of yourself and have a great rest of your day.